You guys are gonna go ahead. Sorry.
All right. Alrighty, we are Porous Pavements. I'm Casey Abel, project manager.
I'm Zach Format, part of the design team.
I'm Haley Bedard, also part of the design team. And I'm Stephanie Bobo, I'm the estimator.
And as Dr. You said, we'll be talking to you about reconstructing parking lots 14 and V2 for Michigan Tech. All right, we're just gonna have to deal with this in our way, I guess. Anyway, here's what we're gonna go over. Our problem statement, the current conditions of those parking lots, what is porous pavement, the research we've done, our NEPA study, all of our preliminary design ideas and our current design, the challenges we faced, our work breakdown structure, the total cost, and finally the hours we put into the project. So here's a problem statement. We were challenged with reconstructing parking lots V2 and lot 14, along with the access roads to them. And we have to use a porous pavement design in order to reduce some flooding in the southwest corner. Our considerations and goals were the feasibility of this design, the material designs of our porous pavement, the parking layout, our cost, the construction schedule, and our ADA requirements. So our current conditions, the known flooding problem in the southeast corner. We didn't have any data under the pavement, so we went with web soil survey for our current soil conditions, which gave us an AASHTO a 2-4, 8-3 sandy soil, which has a good to excellent drainage rating, which means it could possibly be used in our design. We also have a frost penetration of 70 to 80 inches. It's good because Houghton is quite cold, and we have a general location of our utilities. So with this given information of our utilities, we have active storm and sanitary sewers, gas lines, water, electric, and steam vents. The concerns about these immediately were we had some abandoned electric, sewer, and steam lines. No depths on these utilities. The sanitary sewer structures, just because we don't have depths, we don't know where they're at. And the southern water main has approximately 230 feet stretch of pipe that has no known shutoff.
So porous pavement is an asphalt that allows the water to seep through it into the ground below. Usually they will have a stone reservoir along with various other layers where the water can be held until it can be naturally absorbed into the soil below. On this slide, you can see a nice little demonstration of porous pavement. With normal, if you've ever seen water on a traditional pavement, usually it just kind of spreads out and then goes to the nearest flow point. But with porous pavement, it just goes straight down. So here's also a couple pictures that show the difference between traditional pavement and porous pavement. As you can tell, the porous pavement is a lot drier, a lot quicker than the conventional, which is very useful because it can reduce runoff as well as flooding, which is lot 14's problem. For our research, our main document was our UNHSC document provided to us. That, along with some other references, gave us these main points. The stone reservoir should have ergoids of about 30%. It should also have a minimum of a 19-inch thickness for a 500-year storm. Unfortunately, due to multiple constraints, we weren't able to achieve 19 inches for thickness, and instead but it should still be able to be over a 100-year storm, at least. The slope of the pavement cannot be greater than 5% without additional design criteria. And for any areas where there is a higher elevation around the porous pavement, there needs to be a stone edge which is basically just an extension of the stone reservoir that goes all the way up to the pavement. And this will prevent excess runoff and sediment from reaching the porous pavement.
So some of the disadvantages of using porous pavement is that we are limited to a suggested maximum slope of 5%. And this is because the higher the slope, the higher the potential for runoff. So this is especially bad after years of use and clogging over time. So it gets worse. So the porous pavement is prone to clogging problems. So yearly maintenance is required, and that usually consists of a form of jet washing and large vacuum trucks. And this is really important for up here because we get so much snow and winter is so long, and we use sand, and sand would definitely clog the pavement, causing it to not work as intended. The porous pavement also has a lower load-bearing capacity than traditional asphalt, and it's not really appropriate for high traffic and high-speed areas. And heavy loads and sharp turns need to be kept at a minimum. However, some of the advantages are that it is green construction certified by LEED, and it reduces the volume of stormwater runoff from paved surfaces. It also increases the groundwater aquifer recharge through infiltration. It has faster snow and ice melt, improves oxygen and water transfer to any nearby plant life, reduces and cools stormwater runoff, and reduces contamination and pollution in the ground. Some of our NECA considerations are while construction is being taken place, there will be less parking for staff and visitors. The sidewalk may not be usable during construction for safety reasons. The construction related particulate matter and litter is always an issue for any construction. However, the construction could lead to revenue for local businesses, and water will be infiltrating the ground rather than becoming runoff. Some of our biggest challenges were the lack of original plans for both Lot 14, B2, and their access roads. We also have limited utility information. So the southern water main has no known shut off for quite a large span. And we had to make assumptions on all of our utility depths. We also had limited knowledge of the material below the existing parking lot. And we are slightly concerned about the frost depth potentially leading to frost heave in the pavement. The only other thing is the construction detours and backups on US 41 from construction equipment pulling in and out of the parking lot.
So the assumptions we end up making were mostly for the utility depths. The water line, we're gonna stick with a state average of 4 feet. Most of these utilities are of state minimums or suggestions by Dr. Yu. So our electric line should be no more than 1 foot down. The gas line should be somewhere around 3 feet. And we then assume that our steam line will not interfere with our design at all because it is fairly far down. The current parking lot pavement depths, we're going with 4 inches, and we're going to assume it has a gravel base of 6 inches under that. Our sewer line, we're going to assume is 42 inches because that is a state minimum. And the storm sewer, we're going to assume 2 feet based on construction experience and recommendations, but that will be removed as part of our construction.
So for most of our recommendations, we pulled from 2 sources of literature. The first being University of New Hampshire Storm Center, and the second being Wisconsin Asphalt Pavement Association and the Federal Highway Administration. This is just a picture from Oregon State that shows how the runoff will drain into our stone reservoir and eventually into the native materials below. So for our runoff area and rainfall considerations, a 100-year storm produces about 3.7 inches in 6 hours, according to the NOAA. And lot 14 and the surrounding paved areas will accumulate about 18,000 cubic feet in 6 hours. And our stone reservoir will hold about 7,700 cubic feet. But the drainage is continuous to the native materials, so we're hoping that kind of mitigates the difference there. So, but given the job price and the lack of utility information, our current design, we think, will be sufficient. And our current design is going to be 10 inches of the bottom reservoir course with 30% air voids. And then on top of that will be a filter blanket, 3 inches of pea gravel. And then above that will be a filter course. That'll be bank run gravel. That'll be 10 inches as well. And then on top of that, 6-inch choker course with AASHTO number 57 grade gravel. And then on top of that will be 4 inches of asphalt pavement with 16% airworks. So this is a gradation that we did following the recommendations of the University of New Hampshire Storm Center. Between the black dots is where standard super pave asphalt pavement would be. And as you can see, our gradation is much different, but that's to be expected as porous asphalt is much different than standard asphalt pavement. This is a sheet that we drew in CAD. It shows our typical sections. They're a little bit hard to see, but lot V2 and the connecting road will have 6 inches of gravel base, and on top of that will be 4 inches of standard asphalt pavement. And then you can see the cutoff line to lot 14, and lot 14 will have all those layers and porous asphalt.
Some construction considerations. The site will need to be fenced off, and any site drainage will have to flow off-site, likely towards the football courts nearby. And additional signage will need to be added. So some navigational guide signs like closed parking lots and parking lot moved to lot 5, which is near the Rosé. Also some warning signs need to be placed out, like trucks entering highway. Some suggestions. We were planning on starting with lot 14 and then constructing lot B2 to save the porous pavement from any unnecessary issues.
Right, so for our work breakdown structure, I know it's a little hard to see the words. What I wanted to emphasize was the diagram on the right. It shows up initially at the beginning of the semester. We planned for a lot of these events to be done sequentially, but throughout our project, we found that a lot of these could be done in parallel, which was a big time saver for us. For our total cost, we did a cost comparison of using the porous pavement versus just traditional pavement. As you can see, it's a little hard to see actually there. All right. As you can see, the porous pavement is about a third more expensive than just doing a traditional replace. That is mostly due to the fact the installation of lot 14, but the price is also increased by the excavation of lot 14 as well as the addition of the Stonehenge. While the porous pavement is more expensive, we still think it's the better option because it will reduce runoff and flooding in lot 14. The stone edge will prevent anything, sediment and excess water from getting into the pavement. Nobody really likes saying sediment's at the beach, so that'll help. It also has numerous environmental benefits as well as it will help make empty or greener campus.
This is a general construction schedule. There will be 2 phases of construction. The first being the lot 14 and the second being roads, the connecting roads and lot V2. It'll take about a month.
So for our hours, we did come in a lot less than we expected. I would say that's because we worked smarter, not harder. It's also because we overestimated our hours because we would rather shoot to do more work than less to make sure our project is up to standard. So these are our acknowledgements and our references. Big thanks to you for the resources as well as some guidance and references for the individual issues were on the slides. Thank you so much for your time. Are there any questions?
Well, we have a little time for questions, okay? If you have questions, just let raise up, raise your hand and get the questions. And if you guys want to, to make better to repeat what the question is, so that the recorders lines can hear that. Questions?
How often would you have to utilize that service to figure out the sand material?
So the question is for those on Zoom was, how often does the porous pavement need to be cleaned? And our suggestions that would be going to Michigan Tech, we suggested either a yearly cleaning right after the first dry week, say that's next week, like our time, or even a month later. Or we told them to do it twice, one right after all that melt, and then one just before snow flies, just to keep that clean. And if sand does get on there, it won't immediately clog up the system.
This trying for up here at home. I don't know the research finding, but all this grass like this, where we have 70 to 80 inches across. And then you have a lot of loose thaw cycles. So everything exposed underneath.
So again, on Zoom, the question was, what does the climate do to the porous pavement because of our such a deep frost depth? That is a very major concern with our design, because I believe in our calculations, due to the frost depth, our stone reservoir would have 20 inches, but also be 48 inches in depth below our porous pavement. But because of our constraints, we had to shrink that. But with all that water freezing, we do expect it to do something to the pavement. We're not sure. I didn't see too much research on like anything here, but I'm sure Michigan Tech can do what we do best and test it and prove it that it works up here.
I believe New Hampshire had a frost depth of like 40 inches, so it's not that close, but it's something. And they seem to do okay with that, not have too many issues, I think.
Right. Are there any other questions?
Am I allowed to ask a question?
Right.
This was pretty good, guys. I mean, it's like you're a consultant going for the city or whatever. Done that many times in my career. Couple of things that might possibly add in. I know you're done with this, but when you're doing your research, why did you pick to do lot 14 first and then lot 4? They're both pretty small. Do you have, I mean, was there a reason why you weren't doing both at once?
So in order to protect the porous pavement, we'd want to get that layer all built up first and then move on to these rows, because we can use the excess rows in B2 to truck in everything for lot 14. It's just the layout of our parking lots.
I guess I'm getting at is they're pretty small. If you go to bid that, what your contractor would probably want to do it all at once. I can't say a contractor wanting to come in and do 14, build it up. They're gonna flip their plan over and make this pavement. I mean, that's something you might I mean, I was a consultant, I'd have to explain, unless unless the university wants lot 4 open all the time. It's gonna be a tough sell to a contractor. They're, you know, you guys did a good job trying to figure this all out, really good. I worked in the UP, so I kind of got a little more advantage with you guys, but most of the water lines in the UP are about 6 feet deep. But you guys did a good job putting that together, and it was pretty interesting. The only thing I didn't see in your presentation, and I know that you did this to a city or a township, they might ask you what is the over, or how much beyond the edge of the parking lot would you expect to be used? It's like that sidewalk by Fisher, would that be impacted? Would that have to disappear? Or would that be okay?
I don't think so. I think that would be, this is just like I just calculated. I think it would be okay. We'd leave it in place. I mean,
And the sidewalk going by, okay.
yeah, I think that
You guys
would
did a
be.
good job, and I said, those are some questions I know that when I was doing presentations for consultants, they always go something weird, so I tried to. Good job.
All right, if no more questions, please join me. Thanks for the team. Let me do. Thank you. Good job. Thanks, you guys did a wonderful job. Oh, sorry, I did not ask you for those fellows online. Do you have any questions? I did not hear that. So. One more question. Stop recording.